In this video, I will explain how to encrypt text using the Hill Cipher. So the Hill Cipher uses this four-step process to encrypt text. So I'm going to work through an example of how to use these 4 steps. So let's say we want to use the Hill Cipher to encrypt the following plain text, car. Step 1 of the Hill Cipher says map the plain text to the corresponding numbers 0 through 25. So if we have the alphabet that ranges from A to Z, we're going to map those letters to the numbers 0 through 25. So for example, the letter C, we can see that maps to the number 2. So we'll write 2. And then the letter A, we can see that maps to the number 0. So the next number is 0. And then the letter R maps to the number 17. So we have 2, 0, 17. Step 2 of the cipher says create an n-by-n invertible key matrix that contains the numbers 0 through 25. So since our plain text contains 3 characters, our invertible key matrix is going to contain 3 rows and 3 columns. Alright, so let's say we create the following 3 by 3 key matrix, and notice that each of the values in the matrix is between 0 and 25. Step 3 says multiply the key matrix by the plain text vector. So we're going to use these values to create a vector. So let's go ahead and create that vector, 2, 0, 17. So we'll notice that this vector has 3 rows and 1 column. So to multiply this matrix by this vector, we're first going to take this first row and multiply it by the corresponding column values right here. So first we do 3 times 2. So let's write that, 3 times 2. And then we add 12 times 0. And then we add 0 times 17. So if we add these values, we get 6 plus 0 plus 0. So the first value in the resulting matrix will be a 6. And then we're going to repeat this process for the next row. So we'll multiply these values by the column values. So when we do that, we get 35. And then lastly, we'll multiply these row values by these column values. And when we do that, we get 129. So step number 4 says perform modulus 26 on the resulting vector. So what that means is we're going to take mod 26 of each of these values. So all that means is do 6 divided by 26 and then write the remainder. So 26 cannot go into 6 at all. So that would just be 0 with a remainder of 6. So that remainder is what we're going to write right here. Next we do 35 divided by 26, which would be 1 with a remainder of 9. So the remainder of 9, that 9 is what we're going to write right here. And then lastly, we'll do 129 divided by 26. That turns out to be 4 with a remainder of 25. So the remainder is what we'll write right here. So this is our final vector. The last step is we just want to convert these values back to their letter values. So for example, 6, we can see that that maps to a G. So our final ciphertext will start with a G, and then we'll see that 9, that maps to the letter J. So that's our next letter in the ciphertext. And then the last letter will be 25. We can see that maps to the letter Z. So we'll write Z as our last letter. So this is our final answer. The plain text car encrypted using the Hill Cipher turns out to be GJZ.